Hello. Yeah, in this video, I want to show you how to animate a time series. First, we need to load a bunch of libraries, ggplot2 for graphing, gganimate for animation, dplyr for data manipulation, zoo and ttr are for time series data. Okay, so let's load them in here. And I'm gonna set a random seed, n equal to 300, and these are the dates starting from 2025 January 1st, and then we create the original time series. And the second step, we need to create a data frame with only the original and SMA20 and the EMA5. There are different types of moving averages, but I select a simple moving average 20. That's the slowest tracking speed, and the EMA5 the fastest tracking. Okay, just want to show you how well they're tracking the original time series. First thing we need to do is to put the dates and the data points into a data frame with a DF, and then we calculate the SMA20 using the rule means model, and k equal to 20, fill equal to NA, align equal to right. And then we calculate the EMA5 using the EMA function, also DF at the original and equal to 5, fill equal to NA. Okay, once we calculate this, then we need to align the data, start all series at the same time point after SMA20 warm-up. Okay, so this is using the dplyr package. So we are doing some transformations on the DF and select the date original SMA20 EMA5, slice 20 to number of rows of DF, just skip the first 19 rows for the SMA20 warm-up, and then do the longer, and then go to the mutate time index to the row numbers. Okay. All right, then we need to perfect rowing lines animation. So we're gonna create these lines so using ggplot. So this using the DF aligned data set and use the AES equal to date, Y equal to value, color equal to series, group equal to series, and plus geometry line size equal to 1.6, alpha equal to 0.9, scale color. So we have the original to be the red line, SMA20 to be the orange line, EMA5 to be the purple line. Name equal to series, and we can get labels. And then we say the theme minimal to the base size equal to 14. And here's the theme with the plot title and element text size equal to 18, face equal to bold. Pilot subtitle, element text size equal to 12. Legend position at the bottom, legend title, element blank. And transition reveal, so this is important, of time index. And then is AES, the linear, and that's it. That's we created everything in this P object. And now we do the render animation using the animate function from the gganimate package. So the syntax is animate P, we say duration equal to 15, FPS frame per second as 25, width equal to 1000, height equal to 600, render equal to GIF ski render. Okay, and then you can see it's running down there. You see the rendering, the arrow is going to the right. And you can see it's at 8.4 FPS data, and now it's 30 seconds left, 29 seconds, 28 seconds. So it's a countdown there. 24 seconds, 20 seconds, 19 seconds, 17 seconds, 16 seconds. Okay. Now 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. Now it's started inserting images at now 14%, 100% done. Okay. encoding to GIF done. So now if we want to really display the animation, we're just using the print of the anim object. Look over there. Now you can see the orange one is the SMA20, which is slow. It doesn't really catch up to the red line, which is the original. And the EMA is following the original quickly, but not very accurately. Overshoot, undershoot from time to time. Okay. All right. And I think if we use the Hoax average, moving average, then it will be we're tracking the original very, very well. Okay. So I hope you have fun with this example, just to how to visualize, how to animate time series. Thanks for watching. Yeah.